So here we are starting chapter 5, lesson 7, the final lesson we're going to do in chapter 5, excuse me. This is going to be integrals that result in inverse trig functions. We have our 6 inverse trig derivatives over here on the left. And you'll notice once again that arc sine and arc cosine have very similar derivatives. Now take a look at what we have. If you haven't noticed, integrals are just the inverse. So when I take the exact same pattern and work backwards, I get arc sine. Why would we not have 2 different integral rules for this? It's simple. If I have a negative sign in here, I could just take that negative like any other constant and move it out in front of the integral. This could just be negative arc sine. There's no need to ever write the answer to an integral as arc cosine. Arc cosine and arc sine are essentially the same except for the negative. Whoops, I forgot a U. And the same is true for arctan and arc cotan, or inverse tan and inverse cotan, and secant and cosecant. You get the point. So there are only 3 integral rules that you need to work with here. By the way, if you'd like a complete listing of all the integrals we're doing this year, page 385 in your book has a complete list of all the integral rules that we have done and that we will do this year, pretty much. So that's handy. I want to point out one last thing about these 3 integral rules before you write them down and put them on your flashcards and your Quizlets and or your list of integrals. Please practice these. Please try and memorize them. Take a few minutes each day or each week and go through all the rules we've had. But if you recall, in the last section, when we had a derivative with a fraction in it, it just became an algebraic mess. There were so many complex fractions and we had to simplify a little bit. We have the same situation here, but to make it a little bit easier, we have a shortcut. And I'm not going to show you how we got to the shortcut. Just trust me when I say this is easier. If you ever have any number here besides 1, I guess I forgot to write the 1 there. If you have any number besides 1, like 5 or 16 or 25, think of this number right here as a squared. And so when we get our final answer everywhere that it said u, now we're just going to take u divided by a. For all 3 of these rules, it's the same pattern. And it just so happens if a equals 1, this is really easy. In addition, just to make things a little more complicated, and actually because that's the way the math works, arctangent and arcsecant are multiplied by 1 over a. These are the 3 best integral rules to remember. Try and memorize these with a different number, with some value of a involved in it. I'm going to show you a couple examples here, and then we'll move on. When looking at integral problems that may be of one of these forms, if you use normal u substitution, you would realize u is 16 minus x squared. But then when you try and take the derivative, you'll realize there is no x up there to cancel out. This isn't going to work as just u substitution. So look for the patterns. If you see a square root here, and you see a number minus a variable, arc sine, you need to be looking for the pattern that's there. If it had been a square root in the denominator with a variable minus a number, look for arcsecant. You will need another variable out front. And then finally, if there's no square root, but you have a variable and a number, there's a good chance that could be arctan. Next, what I want you to do is actually figure out what would a be. That's your number. Remember, this is a squared, so you need to find out what a is. And obviously, what's your u value, because we're always doing u substitution and that stuff. Once you plug it directly into that integral formula, your answer should be obvious. By the way, I don't care if you write it arc sine or inverse sine. I'm a little bit lazy, so I tend to write this one. Less letters to write. But hey, that's just me. In the next example, I want you to take a look at it. U substitution would not work here. If you plugged it in, you'd realize you would have u's and x's. But one of the inverse trig functions does. Which one is it? By the way, if you have any extra constants laying around, it never hurts to move them out front of the integral symbol. Next, you're going to find out what would your a and u values be. Some people are very attached to the idea that a will always be an integer. You should probably get over that as soon as possible. No matter what they are, you're still going to just simply apply the rule. This is arcsecant. And your final answer is as shown. Please remember to rationalize the number.